Okay, what we're going to do is we're going to look at how we decide the formula of a compound which is bonded ionically. So that's when metals over this part of the periodic table bond with non-metals over the other side of the periodic table. Non-metals like located here. This can be complex because some ionic compounds, like KF at the top, it's a really simple formula. This is potassium fluoride. It's got one atom of potassium, one atom of fluorine. Notice we don't write 1 if there's only one of them there. Similarly, next one's slightly more complicated, but it's just because the symbols for the elements are more complicated. So we've got sodium, which is over here, and bromine over here. And again, there's just one atom of each. It's a 1-to-1 ratio. As we go further down our list, these are all ionic compounds, all containing metals and non-metals. We've got MgF2. So this time we've got magnesium here, fluorine over here, and it doesn't form a 1-to-1 ratio. There's 2 fluorines for every magnesium. It can be reversed. So we've got, in this one, Na2O, so we've got 2 sodiums. Remember, the number afterwards as a subscript always refers to the element that comes before. So sodium over here, we'd have 2 sodium atoms for every 1 oxygen atom we have. And then finally we've got something very complicated with brackets, and we'll come to that in a bit. So how do you find out the formula of an ionic compound? The way to do it, certainly the long-winded way to do it, is to go back to what you were doing last lesson. So here we've got an aluminium atom and an oxygen atom. Both are unstable because they do not have full outer shells. Aluminium has 3 extra electrons, 3 electrons it needs to lose. Oxygen has 6 electrons in its outer shell, so it needs to gain 1 electron. 2 electrons. It needs one there, and 1 here. If this was something like magnesium instead of aluminium, and it had 2 electrons in that shell, that would be fairly easy. The 2 electrons from aluminium would move from magnesium would move across to oxygen, be a 1-to-1 ratio. But you'll notice if these 2 electrons move across, we've still got 1 electron in its outer shell, so it wouldn't work. So what happens with this is they bond in a slightly different ratio. So instead of needing 1 aluminium atom, you actually need 2. Now the reason for this is because aluminium as an atom has 3 electrons in its outer shell. Oxygen has 2. And what you have to do when the numbers are unequal is you have to go to the lowest common denominator. So the lowest number that both 3 and 2 fit into, which is 6. So what we're trying to do with the aluminium is get 6 electrons in total on the outer shell. And you can see we've done that. So we've got these other 3 here. With oxygen, each oxygen atom needs to gain 2, but we need to gain 6 in total. So in actual fact, we have 3 oxygen atoms. And then you'll see this aluminium atom, electron from the aluminium would go there. This one might go here. This one over here. And this one here. And what that means is you get a formula then. Firstly, all of these atoms would have complete full outer shells, and the formula would be aluminium 2, so Al2, and oxygen 3. Now what we've just done there is really complex. If I hadn't had the diagrams drawn out beforehand, I would have had to draw those, figure out where the electrons are going, and then work out the formula at the end. If you're doing that repeatedly or in an exam, it's going to take time. So we want an easier method. And this is where we go back to the periodic table. So if you've got your periodic table, it's going to be really useful for this lesson. If not, if you type in AQA GCSE periodic table, you should get this one. Now the periodic table is arranged by groups. So we've got group 1 here. And group 1 contains elements that have 1 electron in their outer shell. So lithium here has 3 electrons, 2 would be in the first shell, 1 left over for the second shell. Sodium here has 11 electrons in total, 2 would be in the first shell, 8 would be in the second, so that's 10, 1 would be left over for the third shell, so it'd have 1 electron in its outer shell. Same with group 2, but they have 2 electrons in their outer shell, and same across 3, 4, 5, 6, 7 electrons in their outer shell. So something like fluorine has 9 electrons in total, 2 go in the first shell, and that leaves 7 left to go in the second shell. So it's got 7 electrons. Group 0 we can ignore for this. So group 0 have full outer shells. They're not going to take part in the type of bonding that we're going to do about in this topic. They only bond very, very rarely. What we can use that information to give then is the charges for each element in each group. So in group 1, all of these elements in group 1, they always form positive ions, 1 positive, because they'll always lose 1 electron, which means they'll have 1 more positive proton than they will negative electrons. So they form 1 positive, and it's worth writing that in your planner. Positive there, above group 1. Group 2 always form 2 positive. They need to lose 2 electrons because they've got 2 electrons in their outer shell, and that means they're losing 2 negatives. So overall, their charge becomes 2 positive. Group 3 is the same. Okay, they're all 3 positive. Group 6 and 7. Group 7 first are 1 negative. They always need to gain 1 electron because they've got 7. They need 8. So they'll become 1 negative. Group 6 has needs 2 electrons to fill its outer shell. So it gains 2 electrons, becomes 2 negative, and then group 5 becomes 3 negative. So actually, you can know the charges that most of the elements on the periodic table will form just by looking at the periodic table without even having to draw the atom out and the electronic structure. We can use that information about the charges to help us work out the formula of an ionic compound. So here we've got a question: what is the formula of magnesium chloride? So from our periodic table, we know magnesium has 2+ ions, chloride has 1- ions. And what we can do is use something called a bar model to work out the formula of the compounds. You'll notice I'm using squared paper here. It makes it much easier if you've got some squared paper. If not, you can just draw your bars as like 1 centimeter equals 1 charge. So can you see here, I've drawn a bar for magnesium that's 2 squares across because it's got a 2+ charge. I've drawn a bar for chloride, which is 1 square across because it's got a 1- charge. Now, if these things just bonded together, then that wouldn't work because we'd be left something with an overall charge. It'd actually have 1 more positive than negative. It doesn't work like that. Your ionic compound must have no overall charge. So what we actually need is another chloride. So we add in another chloride, and can you see those bars are now equal? We've got 1 magnesium bar and 2 chloride ion bars. At this point, you can ignore the charges because 2+ is balanced out by 2-. And we can write the formula. So the formula would be MgCl2. There's 1 Mg and there's 2 Cl. So we always write the name of the metal, sorry, the symbol of the metal first. This time we've got what is the formula of boron oxide. So boron from our periodic table has a charge of 3+, oxide 2-. So I'll draw my bar for boron. Notice it's 3 across. I'll draw my bar for oxide, 2 across. Notice they don't match, so we're going to need to do something. So I'm working it out and I'm thinking it's going to go to about here, really. About here. So I've drawn in an extra boron, so 2 borons, and then to get that equal, I'm going to draw in 3 oxides. And you'll notice now the same width, charges are equal, actually got 6 pluses and 6 minuses, so we can just ignore them. We're not going to use them now, they cancel out because they're equal. And we'll just write our formula, B2, because we've got 2 boron ions, or 3, because it's got 3 oxide ions. Sometimes we get more complex ions, so this is sodium, nice and straightforward, and the next one is hydroxide. Now hydroxide is a complex ion because it contains 2 elements. Sodium has positive ions, hydroxide has negative ions, so this whole thing, this whole OH has a negative charge. So again, I draw the Na, I draw the OH. Can you see these are the same size bar, so we don't need to modify anything. So we just write down the formula, NaOH. And the last one is probably the hardest one. This one's, what is the formula of magnesium nitrate? So from before, magnesium is 2+, because it's in group 2. The formula for nitrate is again a complex ion. It's got 1 nitrogen. This 3 at the bottom means 3 oxygen atoms. It's not the charge, it's just number 3. 3 oxygen. It has a negative charge. So we draw our bars. Magnesium, 2+ charge, therefore 2 squares. Nitrate, 1 minus charge. It's not 3 minus. Remember that 3 is just the number of oxygens, so 1 minus. So it's got 1 bar. Double it. Bars are the same now, so we can ignore these charges. So we'd have 1 Mg and 2 NO3s. Now if you wrote it like that, you'd be wrong, and you can probably figure out why. This would be MgN O32. We'd have 32 O's, which doesn't seem right. What we want to indicate is that we've actually got 2 nitrate groups, an NO3 group, and that's where the brackets come in. So when you've got a complex ion, that's one with more than 1 element, and you're multiplying it, in this case by 2, you always put it in brackets and put the number that you're multiplying it by outside the brackets. Okay, so you should now be ready to do the rest of the lesson and do some practice.